All right, so I get started then. Yeah, good afternoon, everybody. I have this presentation about WPE, which is a web engine based on WebKit and designed for embedded platforms. So during the talk, I'll give a short introduction about WebKit, a very short overview. And then I will more focus on applications, how you can use WPE in your application, what are the use cases for it, and I probably, if I have time, I'll give a short demo about something I wrote. All right, so I'm Philippe. I'm a WebKit reviewer, a customer committer. I work for a company based in Spain called Igalia. We are working on cooperative, and we are currently about 90 happy Igalians across the world. So what's WPE? So it's based on WebKit, which probably, as you know, was a project started by Apple as a fork of KHTML around 2004. And the main goal for them at the time was to build Safari. And since then, other people joined the projects, other companies, and the community added new ports. I will talk about that later. I'll briefly introduce the WebKit 2 multi-process architecture. On that diagram, you can only see two processes, but nowadays there are more. There's one about network nowadays, one about storage, and there's recently introduced a GPU process as well. So the application is called the UI process in that architecture, and it communicates with other processes using IPC. And all the DOM, parsing, all the things internal to the web engine are done in those processes, like JavaScript and all those things. So WPE is a port aimed for embedded platforms. Traditionally, WebKit ports are built on top of a toolkit widget, a widget toolkit, sorry. But this port is a bit special in the sense that it decouples rendering to dedicated, what we call rendering backends. That means that it gives more flexibility to the application developers, and there's more openness about the platforms that you can support using that model. So that means that the rendering is deferred to another part of the port that is loaded at runtime, basically. And the input events are also handled using that model. So those rendering backends usually require a thing called Wayland EGL, which is a way for applications to share graphics resources between processes. And they have EGL extensions dedicated to that. So there are quite a few backends nowadays. I will just focus on two. The first one is the FDO backend, which I will talk about in a minute. And the other one is the RDK backend, which is developed by companies such as Comcast. And they have deployed it in a wide range of set-top boxes, actually, in the world. So the FDO backend, it depends on EGL. So that means usually if you have a GPU driver that's using Mesa, or probably something that provides EGL, you can have binary drivers. So that backend provides a high-level API for applications to be able to get EGL images from the web engine, and so that they can do whatever they want with that. And then that's also what we recommend as the WPE community. It's the backend used on the build boats, and it's the backend we use the most currently in the community. Then obviously you need a browser or some kind of application. So at Igalia, we are working on a minimalistic browser called COG. It depends on the WPE backend, FDO, And it's really minimalistic. There's actually no window decoration, no nothing. And single web view, although we are working on multi-web view support. And it also can be controlled using dbus. So in your application, you can like remote control the browser using other applications, basically. So as a basic, you need to have a Wayland compositor to be able to run Cog, but since recently, we wrote a new backend that leverages the DRM architecture, and thus we don't really require running Wayland compositor. So that's quite cool because it reduces the dependencies that you need for the application, and if you need a full screen application, you can use that backend. Like kiosks, set-top boxes, UI, any full screen display. And then the rendering is done with DRM. So the Wayland buffers are imported as GBM buffer objects and then rendered using DRM. I have a small use case small showcase for that. It's basically a thing I did in my free time. I was a bit tired of using Kodi at home, so I wanted to have a minimalistic media center, self-contained. So I've built a web extension for WPE, and that can be loaded at runtime by the web process. And in that web extension, I use a UPnP library called libg UPnP. And Zishan is here. Okay. So I use that library to discover the media servers on the network. And then for each server, I modify the DOM and add list elements to the HTML page rendered. So I dynamically build a web page based on what's on the network, basically. And then I can do the video playback with the normal video element. That's standard nowadays in WebKit. So there's a demo. It's really 30 seconds. If you want to look at it on your phone, you can scan that code. Otherwise, I can just move on. But yeah, it's an interesting showcase of what you can do with Cog, and it gives an overview of really what you can do. Another thing I wanted to discuss about is Qt applications. As you probably know, Qt is widely used in the industry nowadays. And if you have a web engine in your application, such as Qt WebKit or Qt Web Engine nowadays, you probably would like to have an alternative because Qt WebKit is not maintained anymore. It has a lot of security issues. And some people don't like Qt Web Engine because it's too big. Yeah. So this is an alternative to those two options you have. So what we did in upstream WebKit, we've built a QML module that can be swapped in instead of the Qt WebKit-based QML module. So if you have an application using Qt WebKit, you can directly use that module, and it will use internally WP instead of Qt WebKit. So what you gain is a maintained web engine with security releases, and so in that sense, it's quite a good advantage. There are some drawbacks, though. It works only on Linux, so if your application needs to run on Windows, you're a bit screwed. And then there's dependency on Wayland EGL, but that we can't really work around. And it works currently in the EGLFS, QPA, and Wayland EGL as well. So that means it can work on desktop and on embedded platforms. So to enable it, you just need to download Qt WebKit, WP WebKit, sorry, and turn on that CMake option called the enable WP Qt API, and then at runtime, you just need to make sure that the SO file is in your import path. And then I have a small code snippet, QML, snippet there that shows how to basically use that WPE view in your application. So the changes compared to Qt WebKit is that you just need to change the import line and the module name. It's WPE view, but in the Qt WebKit world, I think it's a different name. Otherwise, the API is similar. So on-title change here that is already available in Qt WebKit can be used as it is. All right, so, and then the last thing I wanted to talk about is how to use WP in multimedia application using GStreamer. That's a bit of a novel way. Think about streaming browsers or HTML overlays in live TV, for instance. So that could be a use case for WP. Just a brief overview about GStreamer. Who hasn't heard about GStreamer? Nobody? Yes? Okay. So basically, it's a multimedia framework based on graphs. So in your application, you build a graph, and the data flow will flow from the source to the sink, and there will be data processing like decoding or rendering. There's many plugins. I won't go into details, but what I did is write a new plugin that uses WPE, and I built a source element for that, so that the video, the web view can be outputted as a video, basically, as a video stream. And it's quite cool because we have zero copy from WebKit world into GStreamer world using the shared GL context. So there's no memory copies in there. And the use cases, as I said, HTML overlays and streaming browsers. I started, so that's a demo I wrote. On the right side, you can see some HTML, and on the left side, the preview of it with a live video behind. And then you can stream that. I can show it later, maybe. And when you update the HTML, it's updated in the video, of course. So that's for like the TV broadcasting world. It could be useful, for instance. Some ongoing work I've been doing lately on that plugin, adding audio support. I have a prototype already. I need to upstream it. And then navigation events in GStreamer are not really, I've been designed many years ago and needs to be modernized a bit, so I started working on that as well, mainly adding mouse scroll support, touch events, and improving keyboard support as well. So the code is in wpwebkit.org. We have a Yocto layer. The support is upstream in build-out as well. This has been working quite well on IMX6, IMX8M platforms, Raspberry Pi 3 and 4. And it's deployed in the wild already, so you can use it now. I guess I have time for a demo, maybe? Okay. If it works. No. Okay, it doesn't work, but yeah. But you can install it with, there's a flat pack available, and you can install it quite easily on your desktop. I can provide the flat pack ref later on if needed. But I don't have it installed here, so I don't know. No, it's not working. Anyway, so yeah, that's it. If you have any questions, I will be happy to answer. Yes, a question?
So how's platform support? I've seen some support for IMX6, IMX8, right? Anything kind of new and notable in that?
Sorry, can you?
Anything new and notable from like platforms supported by WPE?
Yeah, so I can say that I've been working on, more especially on IMX8M lately, on adding making sure that WPE works with the Edna Viv driver, graphics driver, instead of the Vivante. And apart from that, I'm not sure what you expect, what you're asking about. Yeah.
I think there's one more.
Sorry, quick question. Sorry if it's basic. Just wanted to know what the license for WPE is.
Yeah. So the license is BSD and LGPL too.
Okay, thank you.